Okay, hello everyone. So now we're going to learn about bonds breaking and bonds forming in a chemical reaction. So if you look over here, when a chemical reaction occur, two things must happen, right? Firstly, the O bonds in the reactants, right? In the reactants, what must it do? So we must first break them up. So imagine like when you're making Lego, we got the original parts. We must break up the original parts first, right? So the O bonds must first break, and then after you break up the Lego pieces, then you form it back up. So then the new bonds must form, or we can also use the word make. We must make new bonds, or we must form new bonds. So we must first break, and then we must form. So let's look at this case, okay? Let's look at this scenario. This scenario shows this is what we call methanol. Okay, this is the combustion of methanol, the reaction of methanol with oxygen, right, to produce carbon dioxide and water. When I balance the chemical equation, it will be as such. So let's take a look at the reactants and then the products. So we must remember that for chemical reaction to occur, bonds must first be broken. And when bonds are broken, it's like we must absorb the energy first. So we absorb the energy sort of to earn the energy. So this is like a earning money stage. So you sort of first earn the money to break the bonds, right? After that, when you make the bonds or you form the bonds, right, energy is released. So this is like the energy, the money spending phase. Money spending. So first you earn the money, you absorb the energy to break the bonds, then you spend the money or you release the energy to make the bonds, right? So let's look at what type of bonds are there present in this scenario. So we can see, let me highlight in blue, there is a CH bond, a CH bond, a CH bond, right? There's also in orange, right? There's a CO, that's the only CO. Let's highlight another color. Then in green, there's a OH, and lastly, we have a O double bond. So these are the only bonds that we have in the reactants. So I'm going to write down. So we have the CH3 single bond, we have the CO single bond, and we have the OH single bond, and we have the O double bond. Okay, O double bond. Let's count how many we have. Okay, so for the CH bond, we got 1, 2, 3. However, take note that we got a 2 right in the front. So that means even though I got 3 here, there's a 2 here, so everything must times 2. So that would be, I'll write the working for it, 3 times 2, there will be 6 of them in total. What about the CO bond? See, so there's 1 here, but then there's 2. So therefore, there is 2 CO bond. OH, there's 1 here, right? But there's a coefficient 2 here, so there's 2 OH bonds. And then we got O double bond. So O double bond, and there are 3 of them. So we got total of 3 O double bond. So in this chemical reaction, I need to break 6 CH bonds, 2 CO bonds, 2 OH bonds, and 3 OO double bonds. So these are the bonds I need to break, right? So what are the bonds that I need to form? So I'll highlight again in purple, okay? There's a CO bond here, there's a CO bond, it's the same bond, right? And then we also have in red a HO bond and a HO bond or OH bond. So let's write down. This one is a little less complicated. We got C double bond O, and we got a HO bond. So how many do we have here? I got 1, I got 2, but then because there's a coefficient of 2 there, so I have a total of 4 C double O bonds. There's 1, there's 2, but because of coefficient 4 here, there are 8 OH bonds. Okay, So what happened is that I have to actually break, right, after breaking all of these bonds, right, I have formed 4 COO bonds and 8 OH bonds, right? So I absorb energy to break these bonds and I release energy to make these bonds. So during bond breaking, energy is absorbed. So all bond breaking reactions is a endothermic. Remember, endo, En signifies enter. The energy enter. So the energy is absorbed. It is a positive value for the enthalpy change because you increase in energy. Okay, you increase in energy. During bond making, the energy is released. And during bond making, energy is released. It is an exothermic reaction. Remembering that EX stands for exit, so energy exits, energy release. And because energy exits, I lose energy. There is a negative change in energy, means I decrease in energy. Okay, so keep that in mind, and then I'll see you for the next video.